So in this video we're going to go over the idea of trigonometric cofunctions. So here's the idea. If you have a right triangle and you have a given angle alpha and beta, so you have two acute angles on this 90-degree triangle, you know that alpha plus beta plus 90 degrees has to add up to 180 degrees, or if you're working in radian world, you know that alpha plus beta plus 90 degrees. But what is 90 degrees? Well, we know that we can convert from degrees into radians, so we know 90 degrees times pi radians per 180 degrees will convert us over into radian world because the degrees will cancel, so we wind up getting 90 goes into 180 twice, 90 goes into 90 once, we get 1 times pi is pi over 2. So the sum of the angles, so alpha plus beta plus 90 degrees, or alpha plus beta plus pi over 2 radians, has to add up to 180 degrees, but in radian world, pi radians is equivalent to 90 degrees. So we know that these two things have to be true. And then if we subtract 90 degrees from both sides, we can then solve for beta by subtracting alpha from both sides. So we get beta is the same as 90 degrees minus alpha, or we subtract pi over 2 from both sides, so we get alpha plus beta equals pi minus pi over 2, multiply by 2 over 2 to get the common denominator. We get alpha plus beta is 2 pi minus pi is just pi over 2. And then subtract alpha from both sides, we can solve for beta. Beta equals pi over 2 minus alpha. So this angle beta up here, in degree world, we know it can be written as 90 degrees minus alpha. In radian world, we know it can be written as pi over 2 minus alpha. Those are the two ways that we can write beta, either in degree world or radian world. So if we stick with degree world for a little bit, we'll hold on to this here. We'll hold on to the fact that beta equals pi over 2 minus alpha. Or in other words, pi over 2 is the same as, or equivalent to 90 degrees. And we'll just stick with degree world for a little bit. So let's think about the sine function. So right here I have the sine of theta. And the claim here is that the sine of theta is equal to the cosine of 90 degrees minus theta. So let's think about this. So let's say our angle theta is this angle alpha right here. So what's the sine of alpha? Well, the sine of alpha by definition has to be the side opposite alpha, which is A, divided by the hypotenuse, which has length C. And now I can look at beta on the other side, and I can say the side A that was opposite alpha, what's his relationship to angle beta? Well, he's adjacent to angle beta. And in fact, the cosine of beta would be defined to be the side adjacent beta, which is A, divided by the hypotenuse, which is C. So we see that the sine of alpha and the cosine of beta generate the same side ratio. So that tells us by transitivity that the sine of alpha and the cosine of beta are the same. They are the same side ratio. But what is beta? Well, beta is just 90 degrees minus alpha. So the sine of alpha and the cosine of 90 degrees minus alpha are the same. And that establishes this first result. If we were in radian world, we would get to this step, and instead of replacing beta with 90 degrees minus alpha, we would replace beta with pi over 2 radians, minus alpha. So every result that I see down here, instead of 90 degrees minus alpha, if I were in radian world, it would be pi over 2 radians minus alpha. So let's do one more. We just justified this one. Let's justify the tangent. So the tangent of theta. well, in this case alpha, let's let alpha play the role of theta. So the tangent of alpha. How is the tangent of alpha defined? It's defined as the ratio of the side that is opposite alpha divided by the side that is adjacent to alpha, so A over B. Well, now let's look at beta. How is the cotangent of beta defined? Well, the cotangent of beta is the side adjacent beta, which is A, cotangent beta. Cotangent beta is adjacent over opposite. So remember, the definitions for cotangent and tangent are just reciprocal definitions. So if tangent is opposite over adjacent, then cotangent is adjacent A divided by opposite B. And we see that those two functions, tangent alpha, cotangent beta, equal the same side ratio, so they are the same as each other. But what is beta? Beta is just 90 degrees minus alpha, or pi over 2 radians minus alpha. So that establishes this result. And in math, once you see that the same process is going to generate the same result over and over again, you just say, by similar argument, the other stuff is right. The other stuff. So we would establish the veracity of these other relationships using exactly the same process. And then we want to remember that if we're working in radian world, instead of 90 degrees going here, it will be pi over 2 radians, which is equivalent to 90 degrees. So for example, you might be given something where you're asked to use a cofunction to write an expression that is equivalent to or the same as the sine of 2 pi over 11. I prefer to have used equivalent. So what we want to recognize is that the sine of any angle alpha is the same as the cosine of 90 degrees minus that alpha, or the sine of any angle alpha is equal to the cosine of, if you're in radian world, pi over 2 is the same as a 90 degree angle, so pi over 2 minus alpha. So I look at the sine of 2 pi over 11, which is what I'm given, and I need to determine, am I in radian world or am I in degree world? And I can tell that I'm in radian world not so much by the pi that's here, although that's a hint that I'm probably in radian world, but by the fact that there's no degree symbol. So remember, if there is no degree symbol, then it is radians by default. So here I see no degree symbol, which means this is 2 pi over 11 radians. So using cofunctions, this will be the same as the cosine of pi over 2, which is the equivalent to 90 degrees, minus the angle. The angle is 2 pi over 11. And then you need to get common denominators so that you can subtract those two. So 22 would be the least common multiple of 2 and 11. So I'm going to multiply this by 2 over 2 to get a 22 in the denominator, and multiply this guy by 11 over 11. So this is going to be cosine of 11 times pi minus 2 pi times 2 is 4 pi, all over the common denominator of 22, which is going to equal the cosine of 11 minus 4 is 7 pi over the denominator of 22.